All right, so this is an intercept. So it should be crossing the x-axis where when I graph it? This is what you were saying, Brady. Where is it crossing the x-axis? Rewind to chapter 1. All right, if we were to graph this in intercept form, where does it cross the x-axis? What are the intercepts? But we have to change the sign. Right, there you go, there you go. So whenever I graph this, I should see that. Okay, so let me type the equation. If you look down here, you got a little calculator, a little keypad there that'll let you exponentiate and things like that. All right, so I've got 2 parentheses x plus 1 close parenthesis x minus 2. Oh. Oh my goodness. There we go. All right, so if you look, I can see it's crossing at -1 and 2. If I wasn't sure, you can take your pen, your mouse, your finger, whatever. You can click on that point. It will give you the coordinates of that point. If you look, it's going to give you the x-intercepts. It gives you the y-intercept. What is this point right here called? The what? What's that? The bottom point, that very bottom point. The vertex, exactly. It gives you the vertex. Remember all that we had to go through calculating the vertex? Okay. So it's giving you all this information. I can also trace along and see all the points on the parabola. Okay. So I just want you to be able to graph on this for what we're doing today. All right. Let's look at the next one. 1/2 x squared minus 5. This time, what form am I in? It's quadratic. Remember, I got 3 forms: intercept, vertex, and standard. Standard, right? What's missing? The b is missing, so the b is 0. So normally, I would have to do opposite b over 2a and plug it in, but instead... What's wrong?
No, I can't see the bottom one.
The bottom one? Oh, x plus 2 squared minus 3. All right, 1/2 x squared. Make sure you click this little button and come off of the fraction.
How do you get the 1/2?
1 divided by 2. The fraction, 1 divided by 2.
Nah.
Oh, to get off the fraction, hit this little button to the right here under functions.
You just put the question mark button. That'll be the correct.
Oh, will it? Okay. So now if you look, has everybody got this parabola? Hit the, when you're here, hit the button over so you can now do your x squared. Everybody got a parabola that looks like this? No, Mom won't graph the parabola.
You did put X. Mine dropped it.
I want to see an x up there.
X squared, 1/2 x squared.
You gotta take that X off top.
Let me pause this. All right, so again, I can click 3.1620, negative 3.1620, 0, negative 5. That should be my y-intercept. This is my number on the end, okay? Let's do the next one. What's the form for the last one here? X plus 2 squared minus 3. Vertex, that's right. Plus 2. Kendra, you feeling better?
Plus 2 what?
plus 2 squared minus 3. So I know that my vertex should be at -2, -3. And if you look at my graph, it is at -2, -3. It's crossing x-axis here. There's my y-intercept. Everything's there for me. Okay? Can everybody get a function graphed on your calculator? You can zoom in. You can zoom out just like you would on your phone. If you don't, well, everybody's just touch screen, so you're good. There's a plus and a minus over here also. All right, so let's learn about some polynomials. So you need your notebook for just a second, then we're going to come back to the computer. We will test on this Thursday. It's a short little, it's 2 sections in your book, but it's a little involved, so we do a whole section, a whole test on this. Classify polynomials. When everything's said and done, we'll have about, I'll give you an equation, and you'll have probably 8 or 9 things you'll have to do for that equation in terms of analysis, okay? So the first thing I need to do is tell you exactly what a polynomial is, okay? A polynomial has terms, and the terms here have only positive whole number exponents. The coefficients don't matter. You can have negative coefficients, you can have fraction coefficients, you can have irrational coefficients. None of that matters. It only matters that the exponents themselves are positive and whole numbers. Huh? We probably did talk about polynomials when we were adding and subtracting, I think. Did we do that? Okay. 2x to the 5th minus the square root of 3x. Ooh, shame. This is a polynomial, whereas if I changed it up to make this 1/5, now it's not a polynomial anymore. Yes. No, and the no is coming in like Cheyenne said. We've done this before, this little review. Remember in standard form, since we're positive whole number exponents, we're going from biggest exponent down to smallest, okay? So we want to make sure we have them ordered right. So let's talk about how we classify them. When we have polynomials, they have what we call, and I guess I should, So when we have these polynomials that we've got ordered by their exponent, okay? To the 4th minus 6x cubed plus 7x squared minus. I'm going to leave the x off because we can be missing some terms in between. Okay, but we need to make sure that we order them from biggest exponent down. So let me go over some terminology before we classify them, which I should have done first. This first number, when it's in standard form, okay, it's in standard form here, but when it's in standard form, this is called the leading coefficient because it leads the equation in standard form. Now you have to be careful because it's not necessarily just the front runner there, because if it's not in standard form, if this 7x squared was first, 7 wouldn't be the leading coefficient. So it's got to be attached to that biggest exponent. Which, by the way, that biggest exponent is what we call the degree. And I'm going to put a note down here so you know the degree is the biggest exponent. One other term that you need to know is this number on the end. Do you know what that's called? You should know that one. Constant. Constant has no variable attached to it. All right, so what we do is we're going to classify these polynomials by their degree. I'm sorry. I didn't mean to throw trash at you. All right, so we're going to make a little table. We're going to do the type based on... Actually, make this first column. Let's make it degree. Degree. Then we'll talk about the type or the name. And then we'll do what it looks like, an example of what it looks like. All right, so we're going to start at 0. Freddie, are you watching something over there? Mm-mm. I can see the corner of it off your laptop. If the degree is 0, and if you think about what this means, 5x to the 0 power, anything to the 0 power is what? 1. So this is really just 5. So if I have an equation that looks like y equals 5, okay, that's what we call a constant polynomial. So it's just going to be y equals some number. Let's say y equals a. Okay, and it's just going to be a horizontal line across.
These are all types of polynomials. Right?
These are all types of polynomials, yes. Let's move to a degree of 1. Okay, this time it's going to look something like, and I'm going to use a's and b's as my coefficients here, but you might be used to seeing this with other variables other than a and b. What do you think that is? Somebody said it. Looks like slope, intercept, looks like a line. The type is linear. So this time, remember, slope impacts the direction that it's going, so it could look like it's going uphill. It could look like it's going downhill. Are we confused? We getting it so far? It's not real hard. A degree of 2. This should also look very familiar to you. Plus bx plus c. What does that look like? Standard form of what? What's it look like when you graph something like that?
Like that. I just said.
Several of y'all are doing it with your hands. A parabola, right?
Yeah.
And so that's called a quadratic. So the type is quadratic when you graph it. Y'all are absolutely right. It looks like that. Or like that, depending on that number in front. If the number in front is positive, it's going up. If the number in front is negative, it's going down. I'm only going to make you remember up through 4, so we got 2 more. If we have a degree of 3, and this should be the new stuff to you now. We call that a cubic. So this time it's ax to the 3rd plus bx squared plus cx. We'll say plus d, okay? And what happens with a cubic is it looks a little funny. It's a little different. Instead of just being a parabola like that, it kind of comes around. And they won't all look like this, but I'm kind of exaggerating the humps here. Some of them will, but they'll be stretched out, shrunken kind of thing. Yeah, they won't be sideways. They won't be sideways. Last one. If you notice what's happening as we go through these, I'm kind of adding another hump here, okay? So when I get to a degree of 4, this is what we call a quartic. Quartic. Think quarter. ax4 plus bx q plus cx squared plus dx plus e.
So basically, yes, add on to
You can't see that color? I'm sorry. Let me get another one. Oh, we'll just use that one. Can you see it now, or do I just need to erase it? Okay. There we go. Cortex. So this one adds even another hump. So it starts to look something like this or like this. Okay, and sometimes the humps aren't quite as exaggerated as what they are here, and sometimes they're even more so. It just has to do with how it shrinks or stretches. All right, so there's the type. So any polynomial, now if we go over 4, if we go, let's say the degree was 7, we would just call it a 7th degree polynomial. Okay? Okay, Miss McGee. Let's see what we got to do. Let's talk about some critical points. On your homework tonight, you will be graphing, classifying by the type, telling the degree and the constant, and then you're also going to be labeling and finding the critical points. So critical points, there are several of them. First one we're going to talk about are zeros. And these are really easy. The reason I'm doing so much at one time is because I am letting you use that Desmos, and it makes finding these critical points so easy whenever you graph them. So zeros, you should know by now. What are zeros of a function? What? This is x, y. If that's the graph, what are the zeros, or where are the zeros? On the axis, on the x-axis, okay? So any place that it crosses the x-axis, these are called zeros. All right. What type do you think that is based on the pictures that I gave you? What's that look like? Cubic. It's a cubic. That is a cubic. Good job. We also have, all right, so that's the first kind of critical point we're going to find. I'm going to walk you through one with what I want you to do on your homework tonight. I'm going to walk you through all the steps in just a second. Let's say, how many zeros do you see here? 2. Good job. 0 and 0. How about the y-intercept? What is a y-intercept? On the y-axis, where it crosses, you're exactly right, where it crosses the y-axis. So now I'm going to add something. We also have maxes and mins. Maximum versus minimum. So what happens is anytime minimum, these are sometimes called turning points. Okay? They happen, maximums happen anytime you have something that looks like this, okay? Where it was going up, and then it stopped going up and it started going down. That happens as a maximum. It has a high point there. It's not necessarily the highest point on the entire graph, but it's a high point in that particular area. And same thing with a minimum. Okay? Now, in these maxes and mins, they can be relative or they can be absolute. Relative means it's a hump, okay, and it's a high point. It's just not the highest point. The highest. Whereas absolute is absolutely the highest point on the graph. There is no point that goes up higher. And so minimums do the same thing. Relative. I'm going to say C above because it's the same. Let's look back at this graph, and I'm gonna draw it over on the next page so you can see it well. And I'm not gonna put it on the axis this time. So it looks like this. We already talked about the zeros and the y-intercept, but do you see any maximums in this graph?
Yes.
2 of them, do we agree? Maximums occur at the top of a hill, like the peak of a mountain. So I see 2 maximums. Do you guys agree with that? The question is, are they relative or absolute? I have one of each. You're absolutely right. How about this one? Is this one relative or absolute? Relative. It's relative because although this is a high point on the graph, there is some place on the graph that goes up higher. So the other one is what? Absolute. Because there is absolutely no other point any higher on the graph than that one. Does that make sense? Easy concept? How about a minimum? Does this graph have a minimum? Yes. That's right. Is it absolute or is it relative? Ooh, look carefully. It's relative. It's relative because the graph goes down forever. So there's a point lower on the graph. This point's lower, but it's not a minimum. So it's a relative minimum. Do you see the difference? You said, and you ain't even looking.
I'll write it down.
I apologize.
All right. Let's do one start to finish, and let's do all these different things with it and see what happens, okay? Let's do... This is what you're going to do on your homework, so make sure you write down all these steps. Let's do negative, no, I'm just kidding. Let's do x to the third. Remember, f of x just means it's a function, same thing as y. X to the third minus 5x. Here's what we're going to do. We're going to sketch a graph. So I'm going to have to graph it to see what it looks like. We're going to tell the type, the leading coefficient, and the degree, and the constant, leading coefficient. We are going to identify all max, mins, zeros, and y-intercept. Oh, wait, this isn't even everything. We'll add more to it tomorrow.
All we have to do.
Leading
leading coefficient. All right, so without graphing, we can go ahead and identify some things. What's the type here? Cubic. What's the leading coefficient? Ooh. Leading coefficient's a coefficient. It's the number in front of. Look. 1. If it's not there, it's a 1. Remember, it's got to be the one that's hooked to the biggest exponent. How about the degree? What is the degree here? 3. And the constant? 0. Good job, Tyler. It's not there, so it's 0. It's got to be the one without a variable on it. Okay? Let's switch over to Desmos and let's graph it and see what it looks like. All right, x cubed minus 5x. To the third power, I'll show you. Found it? Well, but you need to know how to do any. So they've got, oh yeah, you see, you did the a to the b? Yeah. All right, so we got x. I'm going to push that a to the b button to do third. X to the third minus 5x. That's a beautiful cubic. Huh? Possibility, I don't know. You can check and see. All right. That looks pretty good. Has everybody got that on your Desmos? All right. So what I'm going to do is I'm going to come over here and I'm just going to sketch it. It's about what it looks like. Where am I? Let's see. Cuts it almost in half. So my axes on here. That looks about right. So I'm going to identify everything on here as I go. All right. And I want to give the coordinates as I do this. So here, and what I'll probably do is I'll mark them as zeros with a Z. But then I'll come down on my paper and say the zeros are, well, if you go back to your graph, they're very easy. You just click on that point. Negative 2.2, you can round to the 10th place. Negative 2.20. What'd you get for the next one? 0, 0. How about the other? 2.20. Easy enough so far? All right, so that's the zeros. How about the y-intercept? 0. This is not only a 0, but it's also a y-intercept. Oh, 0, 0. All right, so that's zeros. That's the y-intercept. Now I need to look at maxes and mins. So let's look at max first. Do I have any maximums? Yeah. Sure I do. We all agree it's right here? Is that absolute or relative? Relative, because the graph's going up forever. So this is a relative max. What are the coordinates of my relative max? Negative 1.2 what? 9.1? Negative 1.3, 4.3. Yeah, I mean, I'm not going to take points off for that or anything. What did I say? 4.3. Negative 1.3, 4.3. There's 2 more things we're going to add tomorrow. They're a little more complicated, but that's about it. And I'll have it, what I'll do is I'll have you, you'll be hooked up to Dino so I can see what you're doing on your computer. But I'll have this laid out for you. Like I'll have your graph on there and I'll say graph this equation. Then I'll say, list all this stuff, and I'll say, what's the maximum, what's the minimum, what are the zeros, what are this, what is that? Yeah. It's not bad. All right, how about minimums? Relative, exactly. Armin, what are the coordinates there?
1.8 and then -4.6.
That's right. It's symmetrical, so they're the same, just different signs. I think I'm going to leave it there for today. That's kind of a lot.
Absolute.
There, it doesn't have one. If it goes up forever and down forever, it doesn't have any absolutes. Mm-hmm. So, but if both arrows were going up, if it did all this stuff in the middle, it would have an absolute min, but not an absolute max because it's going up.